And let's start with running the async code, the side effect, inside of our components. Let's maybe start with adding items to a cart from inside the product item component. That means that in here we have this add to cart handler, and we could of course then not just dispatch an action to our Redux store, but we could also send that data to Firebase, to the backend. We would just have one problem with that. If we just send the product data to Firebase, so the data which we're sending to Redux here, if we just send that to Firebase, we would just store that product data in Firebase. But Firebase, the way we are using it, does not have any logic on its own on the backend. So on the Firebase backend, we don't run any extra code. So if we send some product data there, that product data would simply be added to the database, but all the logic we have in the reducer for checking whether a product is already part of the cart, and if it is, updating its quantity, if it's not, adding it, that kind of logic simply does not run on Firebase, because that's a pretty dumb backend here, the way we're using it, and therefore we don't have such logic there. Now, if you would be using Firebase for a real project, you could add server-side code to it. There is a service called Functions, which allows you to add your own code on the Firebase backend, which can be triggered for incoming requests and which would allow you to transform data on the backend. So it would be possible to integrate this here. And if you're using your own backend built with Node.js or PHP or whatever, if you build your own backend API, then of course you're also totally free to add code on that backend API that does more with the incoming data than just store it in the database. But since this is no course about backend API development and about backend programming languages, that's not the route I will take here. It's something you can do, but it requires knowledge about backend programming languages like Node.js or PHP. And we don't have that here in this course. Therefore, it's important to recognize that the code we need to write on the front end and where we write that code will depend on our backend code. Because we of course have our backend API, our backend server, talking to our front-end application, with help of these HTTP requests and the responses which we send around. Now, if we would have a backend API that does a lot of work, so that does not just store incoming data but also transform it, if we had an API like this, then our front-end application could do less work. It could just send data, like the data for a product that should be added to a cart. It could send that data to the backend, let the backend do the transformation, and then use the response on the front end to then just there hand it off to the reducer, for example, to store that response. So then we could slim down our reducer and basically just take the incoming data, which is coming from the backend and which was transformed there. So let's say the final cart, we could just take that and store that in Redux. That's something we could do then. But that's not the scenario we have here for the reasons mentioned a couple of seconds ago. Instead, here we have a backend that does not do a lot of work. It basically just stores incoming data in the format it receives it in. And that means that we do need to do more work on the front end. There, we don't just need to store data in the Redux store, we also need to prepare that data. We need to transform the data. So exactly what we're doing here in add item to cart and in remove item from cart. We are not just getting the finished cart as a payload on the action. Instead, we get a product and we need to find out how to add it to the cart here in this code. And the same for removing. And that's no problem. And it of course makes 100% sense if we have no backend. But if we do have a backend, it is at least something to be aware of, that depending on the backend and the amount of work the backend does, we could do less work here if the backend would do the work for us. But as mentioned multiple times, that's not the case here, and therefore we will need to find a way to still do the work here on the front end, and at the same time then send that transformed data to the backend without doing that sending inside of the reducer, because we learned that we're not allowed to do it there. So that's the problem set with which we have to work here. And therefore, let's now determine where to best put our code for sending the updated card to the backend if the backend is not doing that work for us, and we therefore have to do it here, and at the same time, we're not allowed to send our request inside of the reducer function. So I hope I could explain the problem set we're dealing with here in the last lecture. And it's not an uncommon problem set that you have a backend which might not be doing all the work you wanted to do it. And therefore we'll now have to find a way around that problem. As I mentioned, we can't send our HTTP request here in the reducer, but that of course then means that we need to find a different way. And here, these two main options where we can run our async code become important again. We can run it in the component or in an action creator. Now, as mentioned, let's start with the component. And here it's the product item where we have this add to cart handler where we send a request. Now, what we can do here is we can also use selector from React Redux and get our current card before it's updated, then do all that transformation which we do in the reducer inside of product item without mutating the state though. That's important. We'll need to take care that we don't do that there. And then we send a request. And here's how that code could look like. I did not write this code together with you because this will not be the final code we'll use because it has problems. You'll find it attached though. You find this code snapshot attached so that you can also run it in your own project. What did I do? I worked on add to cart handler in the product item, and I first of all used useSelector from React Redux to select my cart from there, the entire cart. So this cart state object with items and total quantity. And then in add to cart handler, I create my own new total quantity. I don't change it in the existing state because we must not mutate the state here. And that's important. We can write this mutating code here inside of the reducer function in our slice because Redux Toolkit has this internal transformation for changing our code such that it doesn't mutate the state. But that only applies inside of those reducer methods. In product item, so in a regular component, that's not the case. And if here I would set cart total quantity equal to cart total quantity plus 1, then I would change a JavaScript object in memory, which is also part of the Redux store, without making Redux aware of it, because I would be changing it outside of a reducer function, which is horrible, which you must avoid. So that line, which I selected here, would be super bad code. You must never mutate Redux state, and especially don't do it outside of a reducer. That's why instead I create a new constant which has the updated quantity without changing the quantity in the Redux store yet. And then I do similar things for updating my items. I create an updated items constant where I copy the items in the cart with the slice method. That creates a brand new array with the existing objects, but a new array. Then I get hold of the existing item by identifying it in my copied items. That item, however, will still be an object in memory, which is part of the Redux store, because objects are reference values in JavaScript. So I copy that object into a new object as well. So that updated item is a brand new object in memory. And then I can update properties of that object without manipulating my Redux store. If I would be updating existing item, I would be manipulating my Redux store, not if I create a copy first though. And then I find the index of that existing item, and I replace the current item in my cart with the updated item. Or if we didn't have the item as part of the cart before, I push a brand new object to my updated items array. And then I derive my new cart by creating a new object where I set total quantity to that new total quantity up there, and where I set items equal to my updated items. And then I dispatch a new action because I added a new reducer in the store, the replace cart reducer. I added that off screen, and that simply gets the new total quantity and the new items from the payload and overwrites it in the Redux store. And therefore the payload which I dispatch is an object with a total quantity and an items key, and that's what I create here and what I then dispatch here. And I'm not sending a HTTP request yet, by the way. If I save that with the old action which we dispatched here, commented out, if I go back to my application and I reload, I can still add items to the cart as before, and it works as before. Now I did not change the logic that runs when I click the plus and minus buttons. Now what's the problem with this approach though? The problem is that if we would use this in all the parts of our application where we need to update the cart, so if we would also use it inside of cart item to be precise, then we would need to copy all that logic here, which I added to this component, to the cart item component as well. Or we outsource it into an extra file which exports a function which does this maybe. So then we don't have the code duplication. But still, we'll have another problem. We do the data transformation in some helper function and in the end directly in our components. We don't do the transformation in our reducers. We would be able to get rid of add item to cart if we used this replace cart approach in all the places in the application. And that means that our Redux reducers wouldn't do a lot of work. They just get some data and store it. That can be fine, and if that's your personal preference, that's not necessarily bad, but it's not the main idea behind using Redux. Because when it comes to the question where to put our code, we often have the choice between fat reducers, fat components, or fat actions. So when we consider where to put our logic, our code, then we have to differentiate between synchronous, side effect free code and code with side effects, or code that is asynchronous. And that code which I provided to you in product item at the moment is side effect free. We're not sending that HTTP request yet, deliberately because I want to focus on this other problem we're currently talking about. All this code here just transforms data. It's asynchronous code and side effect free. Now in such a case, if we're dealing with synchronous side effect free code, so if we basically just have some data transformation, so we're on the left side of the slide, then you typically should prefer reducers. Now, if you personally have a different opinion, if you like having your code in the component, that of course is fine. But generally, it is considered a bit better to prefer reducers and avoid action creators or components for that. Now, we still haven't had a closer look at action creators. We will soon, but we did definitely work a lot with components. And you want to avoid putting your data transformation code there when working with Redux. It would be different for asynchronous code or code with side effects. There, you should prefer action creators or components, and you absolutely must never use reducers. So therefore, at the moment, we have a problem. We have suboptimal code because we are performing the data transformation in the component and not inside of the reducer, if we rely on replace cart. And that is suboptimal. That's the reason why we didn't write this code together, because I don't want to keep that code here. But what would be a better way of doing it then? Because we need to prepare it before we send it to Firebase, because we can't send a request from inside the reducer. Now, one possible better solution is actually totally obvious once you see it. Instead of using this approach, which I implemented in the last lecture, and which I'll therefore now get rid of, instead of doing that, and hence I can get rid of this cart selector and of the use selector import. Instead of doing that, we want to stick to the approach from before. We want to dispatch the add item to cart action and do all this heavy work inside of the reducer function. But if we now want to sync our new state to the server, so if we want to update the server with that new state, which we derived on the front end, we can simply switch the order. We can first do the work on the front end and let Redux update its store. And then in a second step thereafter, we send a request to the server. But we don't necessarily need to do that here inside of the reducer function, where we wouldn't be allowed to do it. Instead, we can, for example, do it in the product item.js file or in a totally different file. Let's say in app.js as our root component. There, we can simply get hold of our overall cart by basically using use selector and listening to changes to our cart state. And whenever our cart state does change, we can send a HTTP request. So that's what I'll do here. I'll use selector, which we're already importing, to get hold of my overall cart. And then I'll store it in a constant like this. And now we can use effect, which we import from React, to watch for changes in our cart state. Because you learned that use effect allows you to run side effects, so it sounds like a good choice here. And it allows you to run an effect whenever some dependency changes. So we import use effect from React, and we can then call use effect here in the app component, for example. And we could be doing this in any component. I'm just picking my root component here, but that's not a must do. So here we then define our effect function and our array of dependencies. Now inside of the effect function, I want to send a HTTP request with the fetch API, let's say, and I want to send it to Firebase. So we grab that URL from Firebase, add that here, and maybe target a cart.json node. The .json is Firebase specific. This will create a new cart node in the database and then store the data there. And we want to send a post request because that will tell Firebase to store new data. Or to be precise, actually here, I want to send a put request. That's also allowed by Firebase. And if we send a put request, we also do store data on Firebase. But the difference to post is that the new data will not be added in a list of data, so to say, but that it will override existing data. So when sending a put request, we'll override the existing cart with the incoming data. And that's exactly what we want here. So we can send a put request and then set our request body to JSON stringify. And now here I want to send my cart. So this cart, which I get from Redux, I convert this to JSON data and send it as part of the request. Now, since we're using cart in here, we should add it as a dependency to use effect so that this effect function re-executes whenever our cart changes, which is exactly what we want. Now, the great thing is that use selector sets up a subscription to Redux. So whenever our Redux store does change, this component function will be re-executed and we will get the latest state. So in this case, the latest cart. So that means that effect will also be re-evaluated and it will re-execute if our cart did change. And that is exactly what we need. So with this simple addition here, we will send this HTTP request whenever our cart changes. And we can keep our logic for updating the cart inside of the reducer because we simply switched the order. We first update our Redux store and we're done with that. And then we select the updated store to send a request. And that allows us to keep lean components, create a fat reducer with all the logic, and then perform any side effects that might depend on our Redux state. So if we save this and we go back here, if I reload, if I open up the network tab so that we can see HTTP requests, If I add something to my cart, you see a HTTP request is sent. And that happens whenever I update my cart. And if we go to Firebase, we therefore see the cart there, and we see that here we have the correct cart reflected. If I add my other item to the cart, another request is sent, and the cart was updated again. So that is very, very nice. And that's a very good way of having our side effect logic in a component and keeping all our data transformation logic inside of our reducer, which is where we typically want to have it when working with Redux.